Here we're given the cylinder in the first octant, and we're trying to set up an integral to figure out the volume. And the key is that it's actually in the first octant. So if we were like to try to draw this little graph, like you'd see that the cylinder would kind of make a little positive to negative thing here, and it's going from 4 to 5 in this little junction over here. But it's not going to be the negative side. You're only going to get this slice, the one that's on the positive side, because it's in the first octant. So we can actually kind of take a look at it from this side, because we're going to need that if we want to try to set up these integration limits. So we'll go something like this. First, we know that x is from 4 to 5, so we'll put that on the outside just to make it real easy, so we don't have to deal with too much variables. Know that the outside is always supposed to be constant. Now we could take a look at the inside. Now, if we were going to try to like integrate this like across this way, then you would see that the z limits just go from 0 to 1, and the y limits would go from, well, it would be 0 over here, but whatever the equation is for this line, and that line is supposed to be y squared plus z squared equals 1, but we need the y limit here, so we'll just say that y equals 1 minus z squared, square root. So now we can easily put these things in. We'll actually use, we'll go backwards. We use 0 in the middle here. So that's the, go like this, fyz, and this is for d. Z is first, and then we'll get a dy, and then we'll have the dx. For the dy, we're just going from, again, it's 0 to square root of 1 over z squared, and that should complete our answer.